So part 2 of where we are solving. Now I said, if you remember, for part B, where it says maximum reservoir elevation during the passage of the flood. Now, as I said, if you want, you can use linear interpolation, of course, and then you calculate also the elevations, but then that will complicate your life because you need to do some process, I think twice or 3 times or something. Now there is an easier way where you can get you can be getting the outflow and at the same time the elevation. Okay, now I didn't use this method because I don't have a graph paper where I could plot. Okay, now I'll use the exercise that you are given as an example, but not really showing you the whole lot of the exercise, but I'll just maybe give you some hints so that you understand, and we see how it goes. Okay, now this question, before I come to the hints, okay, now what you do for the for you to be finding also the elevation and the outflows, you need to plot your elevation. This is your elevation here. This is your elevation this side. Sorry. Okay, sorry for that. So this is your elevation this side is your elevation. Okay, then this side here is your indicative storage. Okay, Q2 change in time over 2. This is your indicative storage. So you need to plot elevation against indicative storage. Indicative storage, you put it in the primary x-axis, then elevation on the y-axis, then the output, which is Q2, you put it on the secondary x-axis here. So your graph will look like this. Okay, will look like this, where this is Q, this is elevation, and then this is the indicative storage. Okay, now you start first by plotting. Remember, we already have the values. Okay, we already have the values, so we have created this relationship that I was telling you. So then you start plotting. You plot this indicative storage against this H here, which is the elevation. Okay, then on the same graph you put the output, the outflow on the secondary x-axis. So then again you're going to plot this output here against the elevation. So this relationship is very important. You must create it when you just start solving, because it is very helpful. Okay, be it whether you want to use the linear interpolation, you need this. Okay, you want to use the graph, you need this. In fact, even linear, you need both. So this relationship must be created in case you are not given, and which in most cases you will not be given, because these you can simply calculate by plugging in the values. Okay, now when you plot, you have something like this curve here. Okay, and also this curve here. So the way you move, let's say you have the x value. This is your x indicative storage value of 3. okay, these 3 here. So you should also understand your scale. You move up, you come here, this is the first curve, which is indicative storage against elevation. Okay, then you come this side, you hit the second curve, which is the relationship between elevation and the outflow. Okay, then when you do that, you move up, you look which value is this on the Q here, you read it. Okay, you read that value, that is your answer, and that is the value that you are going to put in there. So let's say, for example, this is 50, maybe let's say this is 20 here. Okay, this is 20. Then at the same time, you are going to get this value here for elevation here, straight here. Okay, let's say this is 0.39, so 0.39. Then when you go back to that table, this table here where we were solving, you just put that value 20 here, and then 3.9 you put it here. Okay, then the rest is the same. You're going to convert the answer that you get, you convert it into million meter cubed, then subtract it from this value, you get this answer, you add these, you get this one. Then when you get this one 4.5, you go back to your graph. So you say this is 4.5. You come here, you say, okay, where's 4.5? Maybe somewhere here. Again, you move. 4.5 is here. You move. Okay. You read this value here, and also you read this value here, and you come back. You plug in the value that you get here. Okay. After putting it, you convert it into a million meter cubed. Subtract the answer from this value here, you get the value for this one, and then you add the 2, they give you this value. Now again, when you get this value, remember this is your x, this is the indicative storage on the graph. Okay, on the graph. Then again, you go back on your graph, and you do the same until all the figures are done. So that is how it is done using the graph. And the only tedious process is when you are plotting this, but it's not even a big deal when you understand what you are doing. And I think we've been plotting since first year, so that can never be an issue. Then as simple as that, you put your values, you put your numbers there. So this is what we are supposed to do. So since they are requiring also for elevation, we're supposed to use the graph, so that we can be getting both figures. We get the figure for outflow, while getting the figure also for the elevation. So when you put these, then you can answer that question. It's very simple and straightforward. Okay, now hope you understand. Going to the exercise that you were given. This one is a bit tricky and is different from the example that we just solved, because literally everything here you need to start from scratch. You need to create all these numbers you're seeing here. I don't know if I can find the question. I think the only thing we're given is the inflow hydrogram. So also it's not even given it's not given as figures, I think. Yeah, it's not given as figures. It's given a triangular, then they give you some coordinates here and there. Say, yeah. Then, but so the hint: draw that inflow hydrograph. It's a triangular inflow hydrograph where they are giving you the peak. So they give you the time at the peak and also the value, I think. Then also the total time. So you can assume if it starts from 0, you can put 0, you draw it. I think I did that. You see? Yeah, here. So 0 up to 36. Then you know the peak time. The peak time, you are told the value which is here. I can't see properly here. This is the peak. You also know the value there. So the dots that you know this one here. Then you put a proper scale. Put put a proper scale, you also know this one here. So you mark here, you mark here, and then also you mark here, and also you mark here. Okay, then using the correct scale, you can just join these. Okay, after joining, now you have something like this. Now because you use the scale, you have the values, and then you're given the maximum value, so you can get the scale also for for y axis. Then also using proper scale here, then you are able to scale out time and also the values, which we did here, or which I did here. So I chose the time interval of 4. You can choose any interval. These values here would differ, but you get the same answer. That's a beauty part. Maybe the only difference it will be maybe point something, which is within the acceptable range. So you may not, you can't get the exact, even that same method I was talking about, the one that I was just explaining previously, you use the same. You get me, I got 59.7. You can get 59.6, 59.8, 59.1. It's still okay. Okay. So then you get these values and the time. Then the tricky part, you need to come up with a storage. Okay, you can make an assumption. Okay, then from the storage you can find because the challenge that I had came up with the storage, but then I realized that if you don't accumulate it, if you don't find the cumulative storage, it will give you a challenge when you try to plot the two graphs. Will just they'll cross each other, then you are already done. You can't do anything. So you define the storage. Now we know storage is simply, if we multiply this inflow times time, then we can get storage, right? So now what we are trying to do is to create these relationships here. I don't know if you are seeing, there is Q here, there is indicative storage here, the same relationship that I was talking about. The example that we did, we were given these values, but we are just creating the indicative storage only. But now this time around, we are creating a storage including everything here. These we come up with them. Okay, then storage, you find the storage, and elevation also you find it. Okay. Using some small easy mathematics topics that you were learning, such as we used to call it Ohmite formula when we were in grade 12. Yes, so basically that is it. When you find this relationship, then now you can plot indicative storage against elevation, and then elevation against this. Okay, now on the storage, you are told, we know if we integrate area, when you integrate area you get storage. Okay, if you differentiate storage you get area. Those are small calculus principles. So we were given the storage, I think in form of a formula or something. Then if we integrate that formula, we get storage. So then we are getting the formula for storage because we have H. Now I want you to pay attention to this. In the area, there is a formula where H is incorporated and you don't have a value for H. That is why you need to create this, my H here. You are seeing these values are not in the question, we just created. Okay, then when you integrate the area formula, then you get the formula for storage, and that is the formula that you're going to use to find all these. Okay, and of course, now remember this one we said we get by multiplying the two, but then getting this, then we can find, because the only thing that we will not know in that formula is the H. Okay, then once we calculate the H, then we can plot on the graph, and then the rest remains the same. come up with the table. Here is the table. Okay, yeah, here I did direct. I didn't want to include the two, put the other column which we had in the previous example. Okay, so I just multiplied. After adding, you add the 2, you add the 2, and then divide by 2, then multiply it by time, divide it by 1,000,000, and then I get this one. Okay, the rest remains the same. Okay, this one is gotten from the initial conditions. Always remember, no, not this one, sorry, this one here, the initial conditions in the question, you get this one. So then we continue. The process is just the same. We find this one, this is our x, this is 0.84. We come to the graph here, say where is 0.84? 0.84, maybe somewhere here. You move, what is the value? The value that you read, you put it here. Okay, you put it here, and also the elevation value. Okay, I guess and hope you've understood. In case there's where you are not understanding, please leave a comment in the comment section. Tell me where you want me to explain more, and tell me what you want me to do for you. Tell me also the next maybe task, an exercise or an example that you would like us to cover, or where you need an explanation, so that then you can write and pass your test, your assignments, and even your final exams. You can as well do well to share to also your young ones, be it second years, third years, and fourth years, so that also in case they're having some challenges, they can put in comments. When I'm free, I can read through, and then I can respond by creating videos, lecture videos, which I can then upload, and then they can watch, so that they can also pass. As you know, in our program we don't have a tutor. So from second year, we only have a tutor in first year. Then from second year all the way up to the time you are done, there is no time you have tutorials. They tell you that no, a lecturer will come and do a bit of that, but you know they are very busy, so we end up not having tutorials. So here we can be helping each other. Please do well, share, and so that everyone is aware. Maybe they can put in what is difficult for them, and then we can help each other. Bye bye. Thank you so much.